Hello, and welcome to the Plastek Academy. Thank you for joining us here today for another segment of our monthly webinar series. My name is Dan Preshak. I am the Vice President of Manufacturing at the Plastek Group, where innovation matters and learning continues. Since 1956, our family has grown and adapted to become a global supplier of all your plastics needs. Over the years, we've become specialized in all processes of plastic injection molding. Fast forwarding 64 years later to 2020, we are still growing. The plastic industry remains an essential business, but the makeup of this need is changing. To help us all continue to adapt proficiently, we started Plastek Academy, teamed up with leading experts who will speak on important topics that contribute to the brand of Plastek, environmental responsibility, sustainability, and more. Today's webinar is sponsored by Uniform Color Company. Founded in 1981, Uniform Color is an innovative producer and full-service provider of high-performance color and additive masterbatch. Plastek called upon UCC for today's presentation as we have found great value in our business relationship for 17 years and counting. Sustainability is a focus that the industry is adapting to, and having a sound environmental management plan helps us meet the partnership criteria of our customers. Indeed, a proactive approach to environmental issues can even bring efficiencies from which we and our customers can benefit. Today I am happy to connect you with our friends at Uniform Color to present Achieving Sustainability Through Masterbatch. To everyone watching, thank you for your support and participation. I hope you enjoy today's discussion.
Good morning. My name is Doug Haberman, and I'm the president of Uniform Color. I want to begin by thanking Dan not only for our 17-year partnership with Plastek, but also the opportunity to contribute to today's installment of the Plastek Academy. More than just supplying color concentrate, Uniform Color is committed to delivering masterbatch solutions that positively impacts our customers' bottom line. These solutions can range from reducing cycle time, to increasing the plastic part's resistance to weathering, to creating plastic surfaces that have antimicrobial properties, or reducing the amount of time that it takes to color change so that customers can maximize machine utilizations. At Uniform Color and the larger Audia group of companies, we share Plastek's commitment to spread the truth that plastics ultimately have a net positive impact on our environment. We are proud to share a portion of the sustainability solutions portfolio that Uniform Color has developed that increases the recyclability of plastics, reduces the use of harmful chemicals, and minimizes the energy footprint required to create beautiful looking plastic parts. Not only are these solutions good for our environment, we also believe that they can be implemented in a way that improves our customers' financial bottom line as well. Implementing these solutions is not always easily done and generally requires collaboration and alignment between the whole supply chain, getting material suppliers, plastic processors, and brand owners together so it can be successfully implemented. That's exactly the audience that we have today, and I'm excited to turn the presentation over to Larry DePaoli and Darren Suter, who are two experts at Uniform Color that have devoted their careers to helping our customers successfully implement and deliver cost-saving solutions. Thank you.
Well, thanks, Doug. I appreciate it. And thanks, everybody, for joining the webinar today. The topic, as Doug had mentioned, is achieving sustainability by using Masterbatch products. Before we get rolling into the topic, I've got a couple of slides that I'd like to talk about that discusses a little bit about Uniform Color. That should only take about an hour. No, I'm kidding. I'm not gonna capture you for an hour to talk about UCC. But UCC is a Masterbatch supplier of color and additives in a variety of industries. We are part of a corporate structure that's owned by a family. The corporate structure is called Audia, Also within that group of companies is Washington Penn Plastics. They are a compounder, one of the top compounders of polyolefins in the world. In fact, many folks on this webinar probably know of Washington Penn Plastics. Well, Washington Penn Plastics also invented a really great technology in the elastomer side of their business, the TPE side. It was so successful that we spun that group off to its own business unit, and that is Audio Elastomers. Also part of the uniform color group would be Audia Liquid Color. This is a company located in France that supplies colorant and additives, but they do that in liquid form, not solid Masterbatch form. And then finally, Southern Polymer, who is a buyer and distributor seller of polymers on the open market, right? So they are also part of our group. Next slide, please. So this is our global footprint. Uniform Color is headquartered in Holland, Michigan. It's that purple circle right around the Great Lakes on the left there. We also have a manufacturing facility in Monterrey, Mexico, and a manufacturing facility in Voderady, Slovakia to support our European operation there. And then, as I mentioned, we have a manufacturing facility in France that supplies liquid. If you happen to be in any of those regions, and if ever you're interested in taking a tour of the plant, just give us a shout. There's some contact info at the back end of the presentation, and we'd be glad to set that up for you. But I would encourage you to do that because the plants are really quite nice, very technically capable, and I think you would agree if you saw them. Next slide, please. All right, so before we get down to the topic, I wanted to talk a little bit about the definition of sustainability. Oxford defines it as an avoidance of depletion of natural resources, right? And in the plastics industry, the typical definition of sustainability is recycling or reusing plastic, basically taking something and repurposing it, regrinding it, remolding it, just using it to be something different than it really originally was intended. But according to Oxford's definition, reduction is also sustainability, and we use nothing more than energy when we're producing plastic parts in the extrusion and the injection molding process. Really, that's pretty much everything we do is we put pressure and temperature on plastic to turn it into something else. So it's a lot of energy. So if we can reduce energy, we also can fulfill a sustainability need. And we'll talk a bit about that during the presentation. Next slide, please. So by the nature of what UCC does, and that is supplying Masterbatch, really the version of colorant that we provide is an element of sustainability on its own. The other way that you can color plastic is by using pre-color. Pre-color is a resin, a natural resin that has been extruded or sent through a reactor. So that's the first step. We have to produce the natural resin. Then that natural resin has to be compounded with pigment. So in a pre-color scenario, 100% of the raw material is processed twice. In a Masterbatch scenario, what that is, that's not one pellet, it's two pellets. It's the natural resin, which has to be produced, and then there's the Masterbatch, the second pellet. Masterbatch then gets blended at the press, and then you mold your parts. So as a result of that, only 4% or less of that equation has to be processed twice. That's the Masterbatch part of it. So just unto itself, we are producing or we are running less material through an extrusion process, meaning that we're putting less energy on it. So just by the nature of what it is really an energy reduction and really pretty substantial. Next slide, please. All right, so UCC's got a lot of topics pertaining to the sustainability effort. We do it because it's the right thing to do, but the real reason we do it is because it's good for our business, right? So we've got some really great technologies, too many for us to have time to talk about today. So what we're going to do is focus on the dark purple forms that you see on this slide. So we'll just run through each of them. The NIR Detectable Black is near infrared detectable black. That's what that means. We'll talk about cycle time reduction. We'll talk about coloring post-consumer resin, and then we'll talk about laser marking, how to replace labels using laser marking. Next one, please. Okay, so the first topic will be the near infrared black technology for recycling. Next one, please. All right, so black colorant, black plastic is probably the #1 color in all industries, and there's a variety of reasons of why that is. In the packaging industry, for example, black is a standard that's used amongst probably just about every company. They have a black version of what they do. And the reason that is, though, is because carbon black pigment is a really great property enhancing pigment. It's a great absorber of energy. It's also pretty inexpensive, carbon black pigment is. So there's a lot of common interest for industries to want to use carbon black pigment, not the least being the properties that it enhances. But that absorption quality, which we consider favorable in a lot of industries, also happens to be the hindrance for sortability at a sorting station that uses NIR technology for sorting. So the trick is to formulate the carbon black colorant that goes into the plastic, and the idea here is to trick the NIR sensor into thinking that it's not carbon black. And that's how we're able to make that work. So let's go to the next slide, and I'll explain that. All right, so here's how it goes. You have plastic that ends up on a conveyor, and then as it goes on that conveyor, it passes under an NIR sensor. The job of the NIR sensor is to identify what the plastic is, because there's a signal that can be sent through that sensor when it's exposed to the polymer. The problem with carbon black pigment, if you take a look on that chart on the right-hand side, if you look at that straight line at the bottom of that is a curve of a typical carbon black formula. You'll notice there's no peak in that curve. So when the NIR sensor is looking for something, some kind of reflective property, it doesn't identify it. And what will end up happening is that that black piece that doesn't have that peak in the curve will get sorted into trash. It won't go into the recycle bin. So what we're able to do is to enhance the black colorant by introducing reflective pigments that put a spike in the infrared range. That way the sensor will pick it up, right? So let's go to the next slide. I'm going to show you why that's not as easy as it sounds. The problem with doing that is it's pigment that we have to put into these formulas, and pigment carries reflective properties. So if I were to add a pigment to a black sample, there's the risk that I could change that color, right? So those peaks that you see are specific pigments that cause that. So what we've come up with is we have found pigments that are able to create that curve, but also doesn't affect color. So black is still black, even if we have the NIR additive included in it, right? And that's really the toughest part of creating an NIR black, is maintaining the color black. So we're able to do that pretty effectively. On the left side, you see a chart, and these are some of our standard products. And what you'll notice about all these products is there's different carriers involved. You have 3 different carriers on these products. And the reason that is because we can create compatibility amongst just about any resin you'd be running, right? So we have these standard offerings that polymerically are compatible with your resin. But the one thing that we would encourage you to do, if you're interested in this technology, is discuss this with UCC, and we can customize a solution for you, for your injection molding process or your extrusion process, and for your parts, for whatever sortability requirements you have. We can customize that formula for it. In fact, we would actually prefer to do that for you, because you'll end up with a much better product if we do that. Next one, please. All right, so now we're going to talk a bit about cycle time reduction. So there's an obvious need why we would want to reduce cycle time in the injection molding or the extrusion process, and that, of course, is that if we can make parts faster, our level of productivity increases, right? So we get basically more capacity on a machine by reducing cycle time. Go to the next slide, please. So what we've been able to come up with is a cycle time reduction additive. Now, there's a lot of cycle time reduction additives out there, and we're aware of that. But the one thing that a lot of these additives have in common is that they're disruptive to the properties of the polymer. Very often, the reduction in cycle time is done during the cooling process of the injection molding cycle. So, a lot of these additives will allow you to cool faster and transfer heat and do whatever you have to do to get the part off the machine. But there's dimensional stability at risk if you take that part off the machine a little bit too hot. So what we've done is we've come up with a technology that improves properties of the part while reducing cycle time, right? So if you take a look at the graphs on the left side, you can see in each case, and what you have there are 3 sets of bars in each quadrant. You've got post-consumer resin, we've got a homopolymer polypropylene and a copolymer polypropylene. And you can see in all cases, we were able to maintain or improve the properties of those 4 aspects in the charts that you see there. But what's most important, at least in my opinion, is the flex mod chart, because what that is an indicator of stiffness. And by creating stiffness in the part, what that means is I can take the part off of the machine a little sooner than I normally would have taken it off, because I need for some kind of structural stability through cooling. I'm able to take it off, and that part can be a little bit warmer than it might have to be cooled down to stay on the machine. And I'm able to do that because this technology can create stiffness in the polymer. This became really important to one of our customers. If you look at the chart on the right-hand side, we had a guy that wanted to replace polypropylene with polyethylene. And there's many reasons why you might want to do that, not the least being cost. But the risk, of course, is that you can't generally drop a polyethylene into a polypropylene application without it somehow messing up with dimensions of the part or whatever properties are important to you. But if you take a look at the data that we have on here, you can see how we're able to improve properties by increasing the amount of the additive. And what I really specifically want you to look at is that flex mod number. So you can see a really, really substantial increase in stiffness of that part. That made this happen, right? That's how this all came about for this customer. Next slide, please. So what they were able to do is switch out of polypro, go into polyethylene. They were able to reduce it from 2 Masterbatch products down to 1. They were able to gain cycle time. So if you can reduce cycle time with an additive and doing nothing more than that, from 68 seconds down to 53 seconds, that's a pretty good savings unto itself. Productivity has gone up, the amount of energy you're using is less, but they also save money on the resin costs, right? So this was a double win for this customer. So this product was just completed fairly recently, and we're headed into production on it. So it's a really, really good success story for this customer. We're pretty happy with that. Next one, please. All right, so everybody wants to try to use recycled plastic. There's a lot of good reasons to do that. If we can reduce the amount of plastic that people are throwing away, there's a million benefits for doing that. But it's also just good for your company, right? It's good exposure for your company to be able to claim that you're successfully recycling plastic into the parts that you're making. So it's just good business to do that. Next slide, please. Now, the problem with recycling post-consumer plastic into color is the color of the recycled plastic, right? And everyone has a story to tell that their waste stream of post-consumer resin that they're trying to recycle has a color to it. If you take a look at the examples on this slide here, you'll see on the left virgin resin. The center resin is a post-consumer resin that we use for coloring post-consumer products. And then the one on the right is also one. So you can see that the left or the center and the right are not as clean and as bright or white as the virgin resin. Well, that's because there's pigment in those, and the pigment came from whatever that product was before it became a recycled product, right? Because you can't get the pigment out of the plastic. It's got to stay in there. So the trickiness here is to figure out a way to color that, because you're actually, when you're formulating using post-consumer resin, you're adding pigmentation to your parts that doesn't belong there, right? It doesn't belong in your color match. It happens to be in the resin, and that's just what we have to deal with. Next slide, please. So all of these colors that you see on this screen were matched in that center resin on the previous screen, that darker post-consumer resin. Pretty amazing, really, if you look at it. We have got some really bright, high chromatic colorants that we were able to accomplish in the color matching process. And the reason we're able to do that, and I think this is probably one of the things that UCC is best at, is we're really extremely good at loading formulas with a lot of pigment. We can pack a lot of punch into a finite area of space, that is the carrier resin of the Masterbatch. So by figuring out how to put more pigment into the pellet gives us the ability to color some of these discolored post-consumer resins. So it's really the key part of being able to do that successfully. At least it's the key part to being able to obtain a color match for you and to obtain some of these bright colors that you see, right? So some of these colors that are on this screen are actually in production today. Next slide, please. Okay, so the last topic that we're going to talk about before we get into questions is we're entitling it Eliminating Labels and Printing. Go to the next slide, please. And what this is laser marking. And so what you're able to do with a laser marking machine is have that laser marking machine etch into your parts whatever wording, images, whatever you want to etch into the part. These laser marking machines have this really great capability through its software where you can download images such as your logo. You can download your logo into the software of the laser marking machine, and that machine will etch into your part, your logo. Now, you can't expect to just take plastic, put it on the laser machine, and get a good, vibrant image like you see on these screens. That's where UCC's laser marking technology comes into play. So we don't supply laser machines. What we do is we supply an additive that is formulated into your color, and then when you mold your parts and put them on the laser machine, the imaging from the laser will be more vivid. You'll be able to see it, and from a design perspective, it'll be much more acceptable to you. You can laser anything without the additive, but you'll see if you try to do that without the additive that it just isn't favorable. It just doesn't look that good. That's where the additive comes in. So some of the examples that you see on this screen here are what we're currently working on. The items on the left side are in production. Those are car seats for children. They used to be printed where they would have ink, a special step where ink would be applied to the surface. And the sustainability angle there, of course, is you've gotten rid of a raw material in this process, right? So less raw material is good for the purpose of sustainability. And in a lot of cases, if you have ink or paint on some of these parts, you can't recycle them. So in this case, you can recycle these. If you look at the images on the right, that's pretty cool. What we did there is we went online and we downloaded some images of some stone effects, some wood grain effects, some fabric effects. We loaded those images, and they were nothing more than just JPEG images, loaded those into the laser machine, and then the laser machine would etch that image into the plastic, and then our additive would allow the laser to react appropriately, giving us that nice bright imaging that you see there. So pretty cool. I think it looks neat that a laser machine's able to do that. Next slide, please. So here's how it works. So there are really two mechanisms that we're looking for when we're putting a laser imprint on a part. Carbonization is one, foaming is the other. Carbonization is the reaction of a polymer when the laser hits the plastic, and what it does is it kind of burns it a little bit, and it creates a black mark, right? So the one thing I can tell you is that you can't do unlimited colors with this thing. So if you have a brightly colored logo, you can't do the colors of that logo. Primarily, you can do black and white. That's really about all you can do, at least to an effective degree. I mean, we could formulate and we could remove a surface, and the color underneath the color of the part might be able to show through, but it isn't going to be very vivid, you know. So we don't want to advertise that we can do bright colors, because it just isn't possible. But that's what carbonization is. Foaming, on the other hand, is a different setting on the laser machine, right? So the difference between carbonization and foaming is simply the setting on the machine. The foaming process, actually, the setting, what it'll do is it'll cause the plastic to bubble up, and instead of burning it and causing it to foam up, you end up with a light mark, right? So you can do a dark mark using carbonization and a light mark using the foaming method. Go to the next slide. So the three components required for a great laser mark would be the plastic, and you can pretty much mark just about any polymer, right? You know, I mean, really probably the prevailing factor is the melt temp of the resin, but it's a laser that we're talking about. So it's a very intense amount of energy in a small area of space, right? So we can pretty much put a laser mark on anything. Then of course the additive, the product that UCC supplies. And then finally, the laser device. And as I mentioned, we don't sell laser devices. We don't endorse any laser companies. There's a lot of great companies out there that supply the product. We do have a capability in-house, and that's actually how we designed the laser additive. You know, we had to be able to do some testing, so we decided we're going to purchase that testing. So we purchased the machine that you see in the image in the lower left there. Which, by the way, they named it after me, the Dominator. The laser machine that we have is an ytterbium laser machine. And what that means is there's a rare earth fiber element to it made out of ytterbium, which is an element. And what that does is that puts us into a wavelength of 1,064 nanometers, and we like that wavelength because there's some flexibility in how you can burn an image into the plastic. The other type of laser that falls into that 1,064 nanometer wavelength category is neodymium, which is also a rare earth element that does the same thing. The difference is the neodymium is generally used for high volume applications. So if you have a lot you need to do in a hurry, sometimes that's the one that people will use. The imaging isn't quite as good, I don't believe, as the ytterbium. That's why we like the ytterbium, because we want a really good, solid Class A surface when we're doing the work that we're doing. But there's a lot of options out there. There's a lot of different wavelength capabilities too. Pretty much, if you talk to a laser guy, they'll set you up with what you need for your particular application. So, next slide, please. All right, so those are the 4 topics that we wanted to run through with you folks today. As I mentioned earlier, UCC's got a bunch of sustainable topics and technologies that we would be glad to talk to you about. In fact, if you're interested in any of these that you see on the screen, we have some contact information on the back end of the presentation. Feel free to reach out to us, and we'd be glad to show you what we have. And as a matter of fact, we have a really cool lunch and learn type of system where we can actually bring samples into you, where you can see some of this stuff in action. I know in a lot of cases right now we're not able to do that, but eventually we'll all be able to get back together and have face-to-face meetings. But in the meantime, we can do this virtually for you, and I think you'd find it most interesting. So maybe there's something in here that looks interesting, that fits into your process. If that's the case, just let us know. We'll be glad to help out. Next one, please. All right, well, thanks so much, everybody. I'm going to hand the presentation back over to Nicole.
All right, thank you, Larry, so much. That was great information, detailed, great presentation. Hope you all enjoyed it too. So as Larry mentioned, my name is Nicole. I am the Plastek marketing manager here and organizer for the Plastek Academy. So I just wanted to hop on with the UCC team really quick to thank you for your participation. And I hope you stay on with us just a little bit more for our transition into our question and answer session today. As you can see on the screen,
Okay.
this is your opportunity. I want to encourage you to take a moment to submit a question or even two about today's topic. As we'd like this to be just one more FYI resource for you and your understanding of achieving sustainability through Masterbatch. If you haven't already, go ahead, glance on over to your control panel. You'll see the text box there, and that's where you can submit your questions. We have probably about 10 minutes, so feel free to submit your questions. Larry and Darren will be back with us shortly to answer those live for you today. So as you take another minute, I just have one more item for you right now. We won't be submitting or distributing this particular slide presentation, but we know that and hope that this information is beneficial to you, that you want to take with you and put into play in your daily operations. So for more informative information outside of today's webinar, you'll notice on your control panel that there are 5 handouts provided for you by UCC and Plastek. A little trick to access them before you leave here today, be sure to click on those PDF links. They will open another window. Go ahead and let those sit there while you submit your questions. And then after you exit the webinar, those will still be accessible to you to print, download, or save to your computer. Okay. All right. I do see some questions popping in, so again, we thank you for those. And we're going to bring Larry and Darren back here in just a moment when they're ready. And without further delay, they will take the floor and get those answered for you. I'll see you in just a minute.
Oh, great, thanks, Nicole. Yep, Darren's gonna join us for the question and answer portion of it. So let's go ahead and get started. So Darren, here's a good question for you. Is NIR sortable black achievable using 100% post-consumer resin?
The answer is yes, with a caveat. It depends on what pigments are already inside that PCR resin. The example that you showed in the presentation of that dark gray PCR versus the white PCR, the dark gray PCR we can assume has carbon black pigmentation in it. So the problem is, of course, is if the PCR has too much carbon black, we don't have a magic way to remove that from the system. So therefore, that's our handicap, is how much carbon black is already there. And if there is too much, or if it's variable from batch to batch, then there's no way that we can achieve a good NIR curve for sorting purposes. So the answer is yes, depending on what the resin is and what the base pigmentation is.
Okay, great, but it is possible, so that's good news. Okay, so the next question is, where is NIR sortable black receiving the most interest?
If you'd like, I can jump on this one as well. So
yep,
in the packaging industry, it seems as though that's the area where most of the interest is, and the reason, of course, is because that's a lot of single-use applications where the plastic is formed into a package to deliver a product to a consumer, and then as soon as the product is consumed, then the plastic needs to be handled in a responsible manner. So there's a lot of pounds in black plastic in the packaging area, and so that's kind of the area where landfill and perhaps incineration avoidance is most important.
Okay, great. All right. Next question, also pertaining to NIR. How is NIR measured with a spectrophotometer, LAB, and what value is good? I can answer a part of that, Darren. The spectrophotometer that most folks have within your company for measuring color generally won't have the capability to measure infrared, right? They're designed to measure the visible spectrum, which would be 400 to 700 nanometers, and the infrared portion of the spectrum falls in a longer wavelength than 700 nanometers. So generally and typically there's a spectrophotometer that's designed to measure infrared. Okay, let's see. Next question is, we're gonna look at, okay, we've got a post-consumer question here. When coloring PCR resin, how is lot-to-lot variability of the PCR resin addressed? I can take that, or you can take that, Darren. What do you like?
Sure, I'll jump in.
Okay.
So as you mentioned again in the presentation, one of the hallmarks of the products that we develop for PCR resin is that they have very high pigment loading levels. And, you know, given the fact that the PCR resin already has some base pigmentation in it, there really are no secrets or tricks other than just brute force overpowering the pigments that are already present in that PCR. So, so number one is just high pigment loadings are maintained through our, you know, the combination of our letdown ratio and the base loading of pigmentation in our colorant. Number two on control would be working with the PCR resin supplier to make sure that we have samples of the gamut of color movement and pigment loading level that particular grade of PCR resin would have. That way we can properly bracket the behavior on our end in terms of what the final color variability might be if you had, for example, a PCR batch of resin that had, you know, twice as much pigment as the original batch that we did our color matching in. That's a very real thing that happens, is not only does the color vary from batch to batch of PCR, but the total amount of pigment inside that resin we know varies as well. So that's really what it boils down to, is being able to characterize that up front, knowing what that variability might be, and then controlling our colorants to give the minimum amount of variability in the final product.
Okay, great. Yeah, good. Okay, next question. I run into issues with black specks when I increase my regrind usage. How can I prevent that? What do you think, Darren? Got an idea?
Well, so the issue there perhaps is that the resin itself may not be properly stabilized for the entire heat history of service that it might see in terms of the first pass through their process and any additional passes after regrind. So one of the value-added products that we've you know, improved our customers' process in this regard is where we know that multi-pass heat stability is an issue, or maybe very high rates of regrind is an issue. We will you know, on purpose formulate that colorant to have additional antioxidant stabilization for multiple heat histories, so that we can eliminate or reduce the possibility of black speck formation.
Okay, great. Next question, also pertaining to PCR. Is it possible to use the UCC technology in KW plastics, KW 621 resin? I believe we've done that, right?
Yes.
Yeah. Yeah, I think we have a relationship with KW, and we've been able to color a variety of the products that they provide. Okay. Are there any companies that manufacture very clean PCR? I can tell you my experience, and mostly we see it in the furniture industry, that a common one now is fishing netting, which tends to be nylon, and you know, that resin tends to be uncolored, so it's pretty clean. I mean, there's nothing that's going to be perfectly clean like natural resin, but I think there are some streams out there where the PCR is fairly clean. I guess that would be considered post-consumer resin, but nonetheless, it is a stream of recycled resin. Next question is, do you have any case studies that we can share on converting polypro to polyethylene in injection molds? Darren, I think that's a good one.
Yes, absolutely. I'm not going to be able to pull it up right here, but my contact information is available through Nicole. So whoever's interested in that, I can definitely share some case studies and examples of moving from polypropylene to polyethylene with our technology.
Okay, great. Next one, also PCR. Have you foamed PCR components, and can we provide samples? I personally have not had experience within our company using foaming agents in PCR. I don't know, Darren, if you have.
No, I don't have any direct experience with that. However, there's no reason to believe that PCR can't be foamed.
Right.
Yeah.
Yeah, that's true. It really comes down to the temperature that you're processing the foaming agent in that resin, and it's not any different than it would be a natural resin. Let's see. Next one is about laser marking. Can the laser marking be utilized on flexible film, 125 milliliter, I think millimeters, packaging applications? And the answer to that is yes. That's the laser mark that's applied to the parts. It doesn't go deep into the part, right? It's really a surface imperfection that's created, and then it just cuts into it, forming the image that you're trying to image. So the answer to that question would be yes. All right, how about we do one more, Nicole, if that's okay. Is there a type of additive that will make PCR color better? What do you think, Darren?
I think probably not. The real issue just boils down to what is inside that PCR resin to begin with, and there isn't a technology today that can remove the ills that are inside the PCR to begin with. All we can do is deal with what we have and try to mask it, really.
Yeah. So, Darren, how about you and I invent something like that and become millionaires?
Okay, that sounds like a plan.
Yeah. All right. All right. Well, thanks very much, everybody, for the questions. That was a good series of questions. We really do appreciate it. Now we're gonna head back over to Nicole. I think we're not hearing you, Nicole.
There we go, guys. All right. So just was reiterating the great thank yous to all of you with UCC, Larry, Darren, Doug, and of course our audience today who engaged with us greatly. So jumping in back here to conclude our webinar for today with the time that we have, and I just have 3 last takeaways for you from today's session. So number 1, please remember that this presentation will be available on demand at our website, plastekgroup.com/plastek-academy for your convenience of rewatching this, and even better yet, going back to share the link with your associates and anyone that could benefit from today's information. Number 2, briefly as you exit the webinar, you will be prompted with a window to participate in a survey on today's presentation. We of course appreciate your feedback, as it will only help us to better provide great customer service to you in the future. And number 3, The Plastek Academy series has a great lineup through September 2021. We encourage you to join us for each and every one of them live so that you can take the opportunity to ask questions and engage with us. However, we do want this to be a great and beneficial series, particularly for you as an individual and your company. So with those announced in advance, you can choose the series and presentations you'd like to participate in based on your benefits. So again, check out those upcoming topics on our website at plastekgroup.com. And as always, until next time, have a great day.